Hello students, so today I am here to discuss one more problem from the GATE 2024, and this question is from condensed matter physics with a subtopic of the crystallography. It's a very easy question. Let's try to solve this. This is a question from the X-ray diffraction, and the question is the X-ray diffraction pattern of a monoatomic cubic crystal with a rigid spherical atoms of radius 1.56 angstrom. So, which type of crystal we have? This is a cubic crystal, and the atoms are spherical. He has taken, obviously, we know that, and the radius is 1.56 angstrom. Okay, and it shows us several Bragg's reflection. बहुत सारे reflection show कर रहा है, of which the reflection appear at lowest 2 theta value is 111 plane. ठीक है ना? So the lowest value means the first peak is from 111 plane. So let's write it. The lowest peak is from 111 plane. ठीक है? Now, next, if the wavelength of the X-ray used is 0.78 angstrom, so if the lambda is 0.78 angstrom, then we have to find the Bragg's angle in the 2 theta form, round off the 1 decimal place. So we don't have to find the theta, but we have to find the 2 theta, okay, corresponding to this reflection, and also told, basically also we have to tell that which type of the crystal this is. So first let's discuss the numerical point of view. So this question from the XRD, so it's a very obvious that we have to use the X-ray diffraction equation, that is the Bragg's equation, that is 2d sin theta is equals to n lambda. There is nothing about the order of the diffraction, so we can take n is equal to 1. So the sin theta value will be how much? Sin theta will be lambda over 2d, okay? And we also know that the interplanar spacing d is equal to, since this is a cubic crystal, right? So the cubic crystal, so we can take d is equals to a over root under h square plus k square plus l square, and the value of HKL is 111. So it will be basically a by root 3. Okay, so d is equals to a by root 3. So the sin theta will be lambda over 2a into under root 3. Okay, this is our equation. Now the point is here. Now just look at this. Lambda is known, but we don't know about the lattice parameter. Lattice parameter is unknown. But the radius is given. The radius of the atom is given to us. So if anyhow we able to construct a relation between radius of the atom and the lattice parameter, then our work will be easy. But the point is how we can get the radius of the atom. For that, or basically how can we get the radius relation with the lattice parameter? For this, first of all, we have to recognize this crystal, that which type of crystal this is. And if you see the option, they are also basically asked that which of the cubic crystal this is, whether it is a body centered or this is a face centered. Okay, so first of all we have to recognize this, that which type of crystal this is. And how we'll do this? We have to look at here. The question is saying that the lowest peak is at 111 plane. Lowest peak is at 111 plane. So for that, we should have the information about the atomic structure factor or the form factor. So as we know that the intensity maxima we got, the lowest value of 111 plane, it is clearly, we can say that is the face-centered cubic lattice. How? Just look at here. So for that I have to rub it. ठीक है, मैं इसको थोड़ा हटाता हूँ. So I will just write down this equation, and just rest of this should be rubbed. Okay, so how I am saying that this is a face-centered cubic lattice? Just discuss this. So the lowest peak is at 111 plane. Okay, now there is a two option, whether it is a body centered and or it is a face centered. So if you guys know that what is the condition on seeing the HKL to find out whether the plane is following the BCC rule or FCC rule, we all know that from the concept of structure factor, that for the BCC, the H plus K plus L, this sum should be even. If this is possible, then we can say that the peak will be present, otherwise it will be absent. Peak will be present. Okay? And if the HKL, the sum of the HKL is odd, then the peak will be absent. Okay? So if you find out that what should be the lowest peak, or what should be the lowest plane for the BCC, so let's start from the very beginning, 100. Let's check whether this sum is even. No. Now 110, whether the sum is even. Yes, the sum is 1 plus 1 plus 0, that is 2, even. So the lowest peak for the BCC lattice is 110, not 111. The lowest peak is at 110, but in the question is 111. So definitely this is not a body-centered cubic. This is not a BCC at all. So other option is face-centered. So face-centered is correct, but let's see about the face-centered separately. Okay, so this is not a BCC because the fundamental, the smallest peak we can observe at a 110, not 111 for the BCC. Okay, now let's check for the FCC lattice. So if you guys know what are the condition on the FCC lattice, okay, so for the FCC lattice, the condition is that HKL either should all even, or all odd. If this condition is following, then we can say that the peak will be present, or we can get a peak, that is intensity maxima. Peak will be present, and if there is a mixed HKL means the even number of even integer is also there and the odd number is also there, then the peak will be absent. So if you see the 111, then yes, integer is all odd, all even, 1 is the odd number, so all are odd. So first condition gets satisfied, that yes, it could be a face-centered, but whether it is a smallest or not, let's check this again. So let's start it from here. What should be the fundamental peak? This is a 100, whether it is follow? No, because there is a sum of, or not a sum, there is a even odd combination. Even 0 is even, 1 is odd, so it cannot be possible. What should be the other one? 110, whether it is possible? No, it's not possible because 1 is odd, 0 is even. This is also not possible. What about 111? Yes, now this is possible. Now this is possible because 111, all are odd integer, and the lowest peak is at 111, and this is for the FCC lattice. So the crystal is face-centered cubic, that's for sure. So two option has been eliminated, so either B is correct or D is correct. Now, so if the structure we have is face-centered cubic, then it's a very obvious that we know the relation between the radius of the atom and the lattice parameter for the FCC lattice, and this is given as R is equal to A over 2 root 2. So from here the value of A will be R into 2 root 2, and the value of R is given to us, that is 1.56 angstrom. So value of A will be 1.56 into 2 into root 2 angstrom. Okay, so like this we have find the value of A, just put the value over there. So the sine theta will be how much? Sine theta will be lambda. The value of lambda is 0.78 angstrom, right? So it will be 0.78 angstrom. Root 3 is 1.732. Okay, and divided by the A, 2 times of A. So it will be basically 4 into root 2 into 1.56 angstrom, right? So when you solve this, you will get theta is equals to, when you solve it, you will get theta is equal to 8.8 degree. But remember, we don't need theta, we need 2 theta. So just multiply by the 2. So the 2 theta value will be how much? 17.6 degree. Okay, so it will be 17.6 degree. So the correct option is 17.6 degree, and the crystal structure is face-centered cubic. That means option B is correct. Okay, so this was a very good question, very easy question if you know the concept of the geometric structure factor and the form factor. So it is a very easy question. Okay. Actually, the trend is in these days, in these last couple of years, they are asking the question from the it's basically the mixed concept of the Bragg's law, form factor, and the Miller indices. So please try to do this type of question. It's in trending and it's a very important question. Thank you so much.